Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from CMI Data Science 2022, problem number 8 and 9. So let's start with problem 8. The problem says that let n be greater than equals 5, be a natural number, and let x is equals to the set x1, x2 up to xn, and y equals to the set y1 and y2. And let f be the set of functions from x to y, and g be the set of bijective functions from x to y. Then the number of functions in f equals n square, or it equals 2 to the n. The number of functions in g equals n square minus 2, or it equals 0. So basically, we need to find the number of elements, the number of functions in the set capital F, and the number of functions in the set capital G, right? So let's see. It's a very easy problem actually, very easy problem. So given x is the set, this x1 through xn, and y is the set containing only two elements. See, n is greater than equals 5. This is also quite important. So the number of functions from x to y, that means just the number of functions, any functions. Number of functions from x to y is actually 2 to the n. Why? Because see, x has two options to map, right? Map to, right? X can map either on y1 or y2. This x1 term can either map on y1 or y2, right? So it has two options. Again, x2, the element x2 also has two options. The element x3 also has two options, and so on. The last element xn also has two options, right? So they have two options. So by the multiplication property, by the multiplication rule, it's 2 to the n. So the set f has 2 to the n elements. That means there are 2 to the n functions in f, right? So option B is true, not A, right? F contains 2 to the n elements. And for G, see, to form a bijective function from x to y, mod x must be equals to mod y. That means the number of elements in this set x must be equal to the number of elements in the set y. They must have the same cardinality. They must have the same number of elements. But here n is greater than equals 5, right? That means the number of elements in the set x is at least 5, right? Where the number of elements in y is only 2. So no bijective function is possible, right? So G has zero elements. Why again? Because see, if x1 gets mapped to suppose y1, then x2 has only the choice to get mapped to y2, right? And the remaining elements cannot map onto anything because they've already been taken by the previous elements, right? So it cannot happen because bijection. But if a function is to be bijective, then it has to be both surjective and injective, right? So they cannot map into the same elements, right? So yeah, there is only zero possibilities here. So G has got zero elements, right? So the number of functions in G is equals to zero. So option B and option D are the true answer to this problem. It's a very easy problem actually. It's a 10 plus 2 problem. So yeah, so let's move on to the next problem, problem 9. So in order to select a debating team, the problem says, in order to select a debating team to represent a school, 7 students from class 12 and 13 students from class 11 were shortlisted and were undergoing trials. The coach had to select a team of 5 students, out of which at least 2 students should be from each class. One out of the 5 students was to be named as team leader, who was to be from the class 12. Two teams with the same members but different leaders are considered to be two different teams. The number of different teams the coach can select is, so basically we have to find the number of possible teams under these conditions. See, the shortlisted students contain 7 from class 12 and 13 from class 11, right? The team must contain at least 2 students from each class, right? So that means there are two possibilities. One possibility, case one, 2 students from class 12 and 3 students from class 11, right? This is one possibility. 2 from 12, 2 from class 12 and 3 from class 11, right? So that means which can be done in 7 choose 2 times 13 choose 3, right? Because there are 7 students from class 12 and 13 from class 11. So 7 choose 2 times 13 choose 3. And after that, a team leader has to be chosen from the class 12. So there are two possibilities. So there are two. So 2 into 7 choose 2 into 13 choose 3. So this is for the case 1. This is the answer for the case 1. Now for the case 2, 3 from class 12 and 2 from class 11, right? This is the other possibility where at least 2 students come from each class. So this is also a possibility. So again, this is now done in 7 choose 3 into 13 choose 2, because now 3 students are chosen from class 12 and 2 from class 11. So 7 choose 3 into 13 choose 2. And after choosing a team leader, because after that we have to choose a team leader. So there are three possibilities now, because there are 3 students chosen from class 12, right? So 3 into 7 choose 3 into 13 choose 2. Now this is for class, this is the case 2. And that was the case 1. So combining both cases, we have the total number of possibilities equals to 2 into 7 choose 2 into 13 choose 3 plus 3 into 7 choose 3 into 13 choose 2, right? This is the answer. Very easy problem actually. Very easy. It just looks big, but it's very easy problem. So yeah, this is the answer. This one. This is option C. So yeah, very easy, right? Option C. So yeah, there you have it. The solution to this problem. So it was very easy, right? Basic combinatorics, nothing else. So yeah, there you have it. So do like, share, and subscribe to the channel for more exciting problems. See you till next time.